Hello again, class. This video is another application of first order ODE. The topics are mixture and RL electric circuits. At the end of the lesson, students should be able to solve a problem in RL circuits applying a first order linear DE and solve mixing problem applying a first order linear DE. So let's start with RL series circuit. So we have the voltage source, the resistor, and the inductor connected in series. The voltage across the resistor is equal to current times resistance. And the voltage across the inductor is inductance times di over dt. So using KVL, summation of all voltages around the circuit is equal to 0. So if we are using the conventional method, the current will travel from positive to negative. That is conventional current. And the current will enter the resistor at positive or higher potential and leaves the resistor at lower potential. Same with the inductor. The current will enter at higher potential and leaves the inductor at lower potential. So if we are looking for the KVL, we can choose between entering or leaving. If we choose leaving, V sub S is positive. For the resistor, negative VR. And for the inductor, negative V sub L equal to 0. Transpose VR and VL to the right side, it becomes positive V sub R plus V sub L. V sub R is equivalent to I times the resistance. And V sub L is L times di over dt. So this is linear DE. So in linear DE, there should be no coefficient next to the derivative. So we will divide both sides by L. So Vs times 1 over L is V sub S over L. Then I times R times 1 over L is R over L times I. Plus L is cancelled. Then di over dt. So this is now our linear DE, linear in I. Then get the IF, e to the integral of R over L dt. R over L is constant, so e to the R over L integral of dt. Integral of dt is t, so IF is equivalent to e to the R over L times t. Next is to use the formula. Before, our formula is y times if equals integral if times q of x dx. That is when it is linear in y. Since our equation is linear in I, this y should be I. Then multiplied to if equals integral of if. Then q of x, this should be q of t. Then dt. Our if is e to the r over L t equals e to the r over L t. Q of t is Vs over L dt. Vs over L is constant, so we take out the constant. V sub S over L integral of e to the r over L t dt. So we'll let u equals r over L t. And derivative of u is du, and derivative of r over L r over lt is r over L dt. Since we don't have R over L, we will divide both sides by 1 over R over L. So this becomes du over R over L equals dt. When the denominator is a fraction, the denominator will become numerator. So this becomes L over R du equals dt. So replace Vs over L e to the u, and dt is L over R du. Then you take out the constant, so Vs over L times L over R integral of e to the u du. And the integral of e to the u is e to the u. L over L cancel, so we have V sub s over R. Integral of e to the u is e to the u, but our u is R over L. R over L t plus c. I times e to the R over L t. We are to find the current, so we will divide both sides by e to the R over L t. So this one is cancelled out, this one also. So I equals V sub s over R plus c over e to the R over L t. Reciprocal, we reciprocate the base, so c e to the negative of R over L times t. So this time we will apply the time equal to 0. At t equal to 0, the circuit is still open. So the current is equal to 0. So what is the current when the time is 0? I is 0. Then V sub s over R plus what is our time? Time is 0. 0 times negative R over L is 0. 0 e to the 0 is 1. 1 times c is c. Then transpose c equals negative Vs over R. So we will replace this c. So I equals V sub s over R plus c now is negative Vs over R e to the negative R over Lt. And this one is the steady current. And the whole equation is the transient current. Okay? So what is common? Common is V sub s. So current equals V sub s over R. What is left here is 1 minus e to the negative R over L times t. So this is the general equation or general solution for RL series circuit. So V sub s is the voltage source in volts. R is the resistance in ohms, omega. I is the current in amperes, capital A, and L is inductance in henries, capital H. So let's have some examples. Number 1. An inductance of L henries and a resistance of 10 ohms are connected in series with an EMF of 100 voltage. If the current is initially 0 and is equal to 9 amperes after 1 second, find the following inductance L and the current after 0.5 seconds. First, write down the given. We have the resistance, 10 ohms. EMF, that is our V sub S, 100 volts. If the current is initially 0, so when the time is equal to 0, the current is 0. After 1 second, the current is 9 amperes. Find the inductance. And And find the current when the time is 0.5 seconds. So our formula is I equals V sub S over R, 1 minus e to the negative R over L times T. So at T equal to 1 second, the current is 9 amperes. So what is the current when the time is 1 second? 9 amperes. So 9. Vs is 100. R is 10. 1 minus e to the negative R is 10. L is missing and the time is 1 second. 100 over 10 is 10. 1 minus e to the negative 10 over L. 1 times 10 is 10. Our purpose is to find the value of L. So start by getting rid of 10, then the 1, then the negative, then the e, then the negative 10. So first we will divide both sides by 10. So 9 over 10, 9 divide 1 over 10 is 0.9. 10 divide 10 is 1, so we have 1 minus e to the negative 10 over L. Then we transpose 1 to the left side since 1 is separated by negative. So 0.9 minus 1 equals negative e to the negative 10 over L. 0.1 minus 1 is negative 0.1. So negative 10, negative e to the negative 10 over L. Then we multiply both sides by negative 1s, so the result is positive. Then, ln both sides, ln 0.1 equals negative 10 over L. Then we multiply L, so that L here will be eliminated. And we also want to eliminate ln 0.1 to the left side. So divide both sides ln 0.1. So if we multiply L over ln 0.1 to ln 0.1, ln 0.1 will be eliminated. So only L is left. Then if we multiply negative 10 over L by L over ln 0.1, L is cancelled out. So we have negative 10 over ln 0.1. Negative 10 over ln 0.1 is 4.34. So we have now the inductance 4.34 Henry. L is 4.34 Henry. Next is to find the current at 0.5 seconds. So at t equals 0.5 seconds, current is missing. Using our formula, I equals V sub S over R times 1 minus e to the negative R over L t. So the current at 0.5 seconds is missing. So I 0.5 equals V sub S is 100. R is 10. 1 minus e to the negative R is 10. L is 4.34. 4.34. Then multiply to the time 0.5. Just use your calculator so we can get the answer. 100 over 10 times 1 minus e to the 10 over 4.34 times time 0.5. Answer is 6.84 amperes. I 0.5 is 6.84 amperes. So we have now the second quantity. Another example. An RL circuit has an EMF of 5 volts, a resistance of 50 ohms, and inductance of 1 Henry, and no initial current. Given V sub S is 5 volts, resistance is 50 ohms, L is 1 Henry, at T equal to 0, the current is equal to 0. Find the current at any time T, so we are looking for any time T. And distinguish the transient and steady state current. Apply that to our formula. I equals V sub S over R, 1 minus e to the negative R over L times T. V sub S is 5, R is 50, 1 minus e to the negative R is 50, L is 1, and T is T. We are looking for I of anytime T. 5 over 50 is 0.1. 1 minus e to the negative 50 over 1 is 50 T. This is our current at any time T. The steady current is Vs over R, or 5 over 50, that is 0.1 amperes. The transient is this one. I of T equals 0.1, 1 minus e to the negative 50 T. That is the transient at any time T. Transient current at any time T. And this is the steady current. Another example. An RL circuit has an EMF of 15 volts, a resistance of 20 ohms, and an inductance of 2 Henry, and no initial current. Given V sub S is 15 volts, R is 20 ohms, L is 2 Henry, initial current is 0, that is when the time is 0. Find IT. I of T missing. The current at 0.025 seconds, so I 0.025 missing. The time is missing, so the current is 0.5 amperes. So let's apply that to our formula. Our formula is I equals V sub S over R, 1 minus e to the negative R over L times T. So when the time is 0.025 seconds, the current is missing. So I, V sub S is 15, R is 20, 1 minus e to the negative R is 20 over L2, and the time is 0.025. So just use your calculator. 15 over 20, 1 minus e to the negative 20 over 2 times 0.025. The result is equivalent to 0.166 amperes. Using the engineering, so engineer mode, 166, 10 to the negative 3 is milli. So, (166) times 10 to the negative 3 amperes, or this one is equivalent to milliamperes. So next missing is the time. At t equal to x, the current is equal to 0.5 amperes. So I is 0.5, V sub S is 15, resistance is 20, one minus e to the negative 20 over 2, missing time. So 15 over 20 is 3/4. So 0.5 equals 0.75. Negative 20 over 2 is 10. Negative 10x. So divide both sides by 0.75. So 0.5 divide 0.75 is 2/3. So 2/3 equals 1 minus e to the negative 10x. Then transpose 1. So 2/3 minus 1 equals negative e to the negative 10x. 2/3 minus 1 is negative 1/3. Negative 1/3 negative e to the negative 10x. Then multiply both sides by negative 1. So positive 1/3 equals e negative 10x. Ln both sides, we have ln 1/3 negative 10x. Then divide both sides by negative 10. X is equal to negative 1 over 10 ln 1/3. Negative 1 over 10 ln 1 over 3. 0.11 seconds. This is not correct. That's it for RL series circuit.